Average Schmaverage. Part 2. Today we're going to look at tipping the balance of an average. We're going to check to see what happens when extreme values get into the mix and how it affects an average. Now what we're going to do first is have you find the averages of these two data sets, because the balancing point is going to be where the average is. So what I'd like you to do is I'd like you to pause the video and find the average of these two data sets. These 5 numbers, add them up and divide by 5, then put your answer here, and then add these up, divide by 5, and put your answer in the blank to the right. Once you're done, unpause the video and check to see if you got your answers correct. So in part A of this practice problem, we add 2 plus 3 plus 4 plus 5 plus 6 and get a total of 20. Then we divide by the number of numbers in the data set, which is 5, and find out the average is in fact 4. And if you looked at this on a number line from 2 through 6, you'd have 2, 3, 4, 5, and 6, and these little X's will represent where these data points are from 2 through 6, and the balancing point is exactly in the middle at 4 for 2, 3, 4, 5, 6. But in this situation, you had 2, 3, 4, 5, 61. That total added up to 75, and 75 divided by 5 is an average of 15. So if we put this on a number line, you'd have 2, 3, 4, 5, and 61 would be way over here. Now, if we were going to put our finger where we would balance this, it would have to be somewhere closer to the left, but then this one little data point pulled that average very far to the right. So this is an example of the data getting pulled to the right. So what I'd like you to do now, in words, explain what you noticed in parts A and B. So think about what I said and think about what you saw, and in your own words explain what you saw as we changed the 6 to a 61. Alright, so on the next page. In that last problem, you saw that the data point 61 really changed the average. This data point is considered an outlier since it isn't close to the other numbers in the data set. It's an important fact since the outliers will affect or skew the average. If the data set is small, one outlier can distort the average to the point of meaninglessness. Despite the problem with outliers, averages are really still important. One of the obvious strengths of using an average is that it uses all of the data. You can't just pick and choose which data points you want to use sometimes, so an average takes all the good and all the bad data and brings it together. It also is important not to look over any data when running analysis. Again, you might be seen as scientifically biased if you start throwing out extreme examples. Lastly, the average is very well universally known, and it doesn't require a lot of explanation when you mention it in public or maybe on a research paper or even in passing on a Facebook post or in a news story. So in words, take what I just said and talk about one advantageous and disadvantageous characteristic of an average and as the measure of a middle set. So in your own words, write down on the answer sheet a pro and a con to using an average. Now it's time to reanalyze these 3 teachers who were talking about each other at the start of the worksheet. This is in the previous video of Average Schmaverage. Reread their comments about their classes. From their testimonials, they seem like 3 completely different groups. Now let's take the average of each class and find out statistically what they are. So I would like you to now pause the video and take the average of these 3 data sets. To speed up your process a little bit, I will tell you that each of these classes had only 10 students or 10 data points. So once you've added up your numbers, divide each of these by 10 and put the average in the blank that is marked next to X bar. Alright, now that you've done that, I think you've found something that was pretty surprising. That each teacher thought their classes were way different. This is a class that the teacher number 1 talked about as being, really strong, with only a few students doing poorly due to attendance issues. Well, it turns out the sum of these numbers is 72.5, or sorry, 725, I apologize, let me erase that decimal there. And 725 divided by 10 is 72.5, or a C- average. Now, this is a class that the instructor said, wow, a lot of struggling, a lot of low students, very few exceptional students, well, maybe a few. And you can see that there were a lot of D's and some C's here, and only 2 A pluses. But if you add up all these numbers, you get 725, divide that by 10, you get 72.5. Huh, same average for two different classes. The two teachers said, wow, I mean, they were totally different. And the third teacher said, man, my class was, all over the place with maybe a few notable exceptions, but look at these scores. You're spread from, F to A, and if you add up all these numbers, just like you did in the last two examples, you have 725, again, of 72.5. So these three instructors had three different explanations of their classes, but oh my goodness, they have the same average. This is to basically start to get you down the thinking that an average sometimes doesn't tell the whole story. But let's take a look at the data sets and figure out why they all had the same averages, despite being three different types of groups. Now, what I need you to do is maybe some pre-thinking, pre-thinking here. This is to explain in words why the teacher said, wow, I had a great class, lots of hardworking students and only a few low students due to attendance issues. And explain why teacher number 2 said, well, I quite the opposite. Most of the class couldn't get it together and there was only a few getting the job done. And also put in your comment of this teacher who said, my students were all over the place. No standouts for this semester. Well, a few, but not a lot. So please write down your answers in those blanks. And the answers may vary, but they all kind of correspond to what I talked about in the previous problem. All right, now, here's your chance to split up your thoughts about which teacher said which. Now, you can read the explanations in above to what teacher 1, 2, and 3 said, but I would like you to take a look at this graph, and these graphs represent the students' grades from high to low. In fact, I want to highlight what the x-axis is saying, although it may be apparent, but it may not be apparent. Imagine that this bottom percent down here would be at 0, and this top percent would be at 100. Because here we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Whoops, I was off a little bit. Looks like that bottom number is going to be 10 here, and this is going to be 100, and this is going to be 110. I apologize. And the reason why we would see that there are two scores here between 100 and 110, so starting at 100 going to 110. So here's a bunch of D's, and here's some C's, and here's some A's. Here's a bunch of B's and A's and a couple on the low end, and this just seems to be all over the place here. So why don't you decide which teacher said which, and then pause the video and check to see if you got it right. Alright, so if you're checking your answer, this would be teacher 3, the person who said that they had all over the place. We had some 50s, 60s, 70s, 80s, and 90s. This would be teacher 1, where most of the students got, between, your high scores here, but very, some way down at the bottom. And here's teacher 2. Teacher 2 saying, man, a lot of 60s, 70s, and then, maybe a few, very few students in the hundreds right here. So that is the answer to these three sets here.